Are you all good to start?
Yep, I'm ready.
Well, good afternoon. I'm Dr. Kay Stefanik, Assistant Director of the Iowa Nutrient Research Center. I want to welcome you to our Fall 2025 seminar series, Working Towards Better Water Quality Through Regional Collaborative Research. We have three speakers today. Dr. Peter Moore, Adjunct Assistant Professor in the Department of Natural Resource Ecology and Management here at Iowa State University. We have Amanda Brown, Conservation Ecologist with Polk County Conservation, and Juan Arellanes, Water Resources Engineer with JEO Consulting. And they're going to be presenting their work on engineering with nature, co-designing two-stage channels for cleaner water and resilient landscapes. And I have a few housekeeping items before we begin. First, this is a hybrid meeting. For those of you online, you can type your questions into the chat and I will ask them at the end of the presentations. For those of you in E-Lings, you can just raise your hand and ask at the end of the presentation. Secondly, this webinar is being recorded and it will be posted to the INRC's website along with previous seminar recordings. All right, with that, the floor is yours.
All right, thanks, Kay. Thanks for joining us this afternoon, everybody. As Kay said, my name is Pete Moore. I'm on the faculty here at ISU, and I'm a collaborator on the project that we're discussing today. Sara McMillan would have liked to have been here, and she was originally scheduled to present the first part of this presentation, but she ended up being double booked today. So I'll do my best to cover the research angle on this project. See if I can advance. That looks good. So here's how we'll proceed with the presentation. I'll start by describing what two-stage channels are and how they work. And then I'll hand the reins over to Amanda Brown, who will talk about opportunities and challenges of integrating practices like two-stage channels into the portfolio of conservation and water quality practices in the real world. Amanda will pass the baton to Juan Arellanes of JEO Consulting, who will discuss some of the key partnerships formed over the course of this project, the co-design process that emerged. And is that a sound that's specific to me, or? I think that's my speakers are doing something weird. Can you all still hear me?
Yeah, we can hear you.
Okay. I might not be able to hear you for a minute, but that's okay. So anyhow, the last bit will be some sharing of lessons learned that have emerged so far in the process. So hopefully everybody's ready to go, and I'll get started. All right, so agricultural drainage ditches are really an important part of the agricultural production process in some of the richest soils in the world, like around here on the Des Moines Lobe in central Iowa. But ditches can also be problematic because they're part of a fast track for sediment and excess nutrients to enter our surface waters. Traditional trapezoidal ditches they often require maintenance because, like natural streams, they erode their banks and sometimes deposit sediments on the ditch floor. Now, if they're left alone, most of these ditches would probably eventually evolve into relatively stable natural streams with floodplains on the ditch floor, but this can take decades or even centuries for that process to happen naturally. Two-stage ditches are ditches designed or retrofitted with an inset floodplain, like the natural streams, and also like what's illustrated on the bottom of the slide here, that have an inset floodplain that can be accessed at relatively modest runoff volumes on either side of the channel, along with the inset channel itself. The inset channel is usually sized so as to contain low flows with enough energy that it keeps the bed of the stream from silting in, but sufficiently low banks to be able to allow for relatively frequent inundation of the floodplain. That vegetated floodplain is a key part of the two-stage ditch design because it provides opportunity for flows to spread out, access roughness, deposit sediments and phosphorus and trap them locally and allows organic matter accumulation and denitrification while maintaining conveyance of floodwaters. Two-stage ditches have been used in small catchments, relatively small catchments, less than about 10 square miles of drainage area, and where ditches have relatively gentle bed slopes, less than about 0.5%. Also, it's important that bank heights are relatively low so that banks don't become prone to slumping, extensive slumping. And it's important also to have perennial flow to maintain flow through the inset channel and prevent sediment accumulation within that inset channel. One nice feature of two-stage ditches is that it's possible to implement the practice while in the process of doing ditch maintenance or other conservation practice implementation. So far, however, there isn't really much data or information that can substantiate the effectiveness of two-stage ditches or two-stage channels for nutrient reduction in Iowa specifically. There is prior research elsewhere in the country, but we'll see that those results may or may not apply in places like Iowa. So some of this previous work that's taken place mostly in Indiana, Michigan, and Ohio demonstrates that two-stage ditches can substantially reduce in-stream turbidity compared to regular ditches or conventional ditches. Phosphorus delivery between upstream of a two-stage ditch and downstream is significantly, although modestly, reduced in terms of dissolved phosphorus. Or soluble reactive phosphorus, and relatively short segments of two-stage ditch do substantially or significantly reduce dissolved phosphorus export from those studies in the Great Lakes states. Also, we know, even though it was not specifically documented in those studies, that the deposition of sediment and particulate phosphorus on these low bench floodplains in the two-stage ditches can certainly contribute to both sediment and phosphorus reduction in export waters. On the nitrate side, there's evidence for greater denitrification and nitrogen removal of up to a factor of 24 in some cases, and that this effect increases over time. So nitrate was lower when compared again upstream to downstream across two-stage reaches, was significantly lower on the downstream end of these two-stage ditches. So two-stage ditches evidently enhance denitrification primarily by allowing access to this additional reactive surface area in these inset floodplains. So the motivation for our work here in Iowa, and this is supported by the Iowa Nutrient Research Center, is to understand or try to better understand whether two-stage ditches will work for nutrient retention and removal in Iowa-specific settings. Again, the studies in Indiana, Michigan, and Ohio suggest that both sediment and phosphorus, as well as nitrates, can see some reduction in the presence of two-stage channels. So our goal is to basically compare a newly constructed two-stage channel to a control system, as well as to a naturalizing ditch, which is one that basically has not seen any recent ditch maintenance, and any deposition that's happened within the naturalizing ditch floor is allowed to sort of anchor and become a naturalized inset floodplain in those ditches. Specifically, our goals are to test the hypotheses that constructed or naturalized two-stage channels will maintain conveyance and reduce flooding, that improved floodplain connectivity will increase sediment and phosphorus trapping, and that the benches in particular will help to enhance nitrogen removal through higher rates of denitrification. And our approach has basically been to design a before, after, and control impact study where we compare measurements in a ditch before it's converted to a two-stage ditch, a control section that's left alone basically and nearby, and then additionally compare with one of these naturalized two-stage ditches or one of the unmaintained ditches. And our locations are mostly in the Chautauqua Bottoms Park in Polk County, as well as one site where the naturalized two-stage is occurring in Walnut Creek in Story County, just outside of Ames. Now, working in these locations and setting up the research here has been something that would have been difficult for us to do alone. And this is where we start to have to bring in the work of our partners. So I'm going to turn it over to Amanda here to talk about our partnerships.
Thanks, Pete. Can everyone hear me? Hopefully. Good. Okay. I'm seeing head shake from Juan, so I think I'm good. Again, I'm Amanda. I'm a conservation ecologist here with Polk County Conservation. So just kind of setting the stage, Pete and Sara, they had their goals of what they wanted to see in research in a two-stage ditch. So then it's finding a location. So they reached out to us and we kind of visited the location and seeing if it would work on our end. So I do have a map here that I like to put on there to kind of show perspective. For those of you who aren't familiar with Chautauqua Bottoms Greenbelt, it's basically everything in red there. It's one of our public county lands here in Polk County. And the little diagonal channel you can see there, that's the South Skunk River. So it actually flows through your guys' area too. So I like to show that map because really Chautauqua is about 10,000 acres that we manage, and this project is just kind of integrated into that landscape. You can see I called out the project location, and we'll zoom in on another map on another slide here. You can see that that's not technically within our public ownership yet, but it will be soon. So that's why it's not highlighted in red. So when we were approached, it was very much like, how can we match our goals as different organizations that are looking at different goals? So here in Polk County, we definitely have the goal of water quality. So it checked that box for us right away, looking at, do these ditches or do these two-stage ditches improve the quality of water as it comes into Chautauqua? Because as you can notice with the project location, everything above that project location is agriculture. So it's areas that we don't control in as an organization, and maybe have a little more nutrient runoff and compared to some of our public lands. So it met that goal, of course. And then one other kind of opportunity that came along, it was a great opportunity because we already had a project in the area. And so you can see that other little inset map there, where we already had kind of a pumped wetland type system where we were trying to pump water out of this drainage ditch number 4. That's in the square there. And then you can see that long kind of linear dashed out areas where the two-stage ditch was going. So this worked really well for us to pair these two projects together. So it met our goals there of, we're going to be putting in this pump at the very bottom of this ditch, and we really don't want this pump to get clogged with sediment. So if we can show that this two-stage ditch here within this channel is helping reduce that sediment within that water, helping it settle out there on those benches, that's going to protect our investment downstream of this pumped wetland. So again, meeting those goals of ours, but then also pairing those with Iowa State's goals of research. One other kind of neat thing about this site that met a lot of our needs, and I think will meet Iowa State's needs as well, is in some of our bigger partners too, is this can serve as a great demonstration site. So it's right along a roadway. It's really easy access. You'll be able to kind of park right on the roadway and walk and see it. And you can even see it from the roadway. And then with it being in public ownership, people will be able to come out and see it as they please. So again, meeting those partnership goals of all the partners involved. And then finally, in the Polk County side, we really wanted to be able to meet local needs, and I'll talk about those in another slide. But we really had some local needs we were trying to meet, not just our own. Again, another partner, as Pete already talked about in length, is Iowa State University with their research and bringing in that expertise that we don't have on our side. So that was a really great thing to throw in there and have that partnership there with Iowa State. And then finally, one challenge we always run into as a public entity, especially, is limited funds, right? So we have limited funds. We have to spread them across 16,000 acres here in Polk County. So it's how can we bring in other partners and meet their goals to maybe get some funding to do these projects. So the Iowa Department of Ag and Land Stewardship has their statewide goals, of course, of nutrient reduction, the nutrient reduction strategy that a lot of you all probably help with. So really trying to reach out to them and seeing, hey, does this project meet your guys' goals? Are you guys interested in seeing the nutrient removal of these, or the nutrient removal benefits of these two-stage ditches to potentially integrate them into the system? And I know that's definitely a goal of Iowa State as well, is trying to figure out, what kind of nutrient reduction are we seeing in these? So the Iowa Department of Ag and Land Stewardship was very interested in this project and has agreed to put funding towards this project. So again, another partnership there. And Juan will talk a little bit, it's also integrating all of these partners. It's great to have a lot of partners, but then you have a lot of opinions, a lot of needs from the various partners that you have to integrate into the design. And he'll talk about that when he starts talking. But if you want to go to the next slide, Pete, I'll talk a little bit about some of those local needs. So um, I always want to point out with this project that it's on a drainage district ditch. So this is a legal drainage district. It's called DD4. If you look in the map, it kind of comes down. There's a little wording that says DD4. That's the ditch. Yep. So it comes down and then enters into Chautauqua. So it is a legal drainage ditch. And basically, the purpose of this drainage district is to get water off of the landscape for agriculture. So it's really important that this ditch continues to function and kind of shed water off the landscape and move it through the system, which again, Iowa State University will be looking at through their research to make sure it's doing that. This drainage district is currently managed by the Board of Supervisors, so it does not have a private Board of Trustees. But again, because it's an official drainage district, we do need approval from the Board of Supervisors in order for this project to move forward. So it's not enough for just us as landowners to be able to say, yes, we want to be able to do this on our land. We had to get approval from the managers of the drainage district. And I think this is going to be applicable to probably a lot of sites throughout the state. Maybe some that are managed by local government organizations, but then some that are managed by private landowner trustees as well. We partner a lot with these private landowners upstream of Chautauqua, just because what we do at Chautauqua can impact their agricultural lands and things like that. So we definitely wanted to get support from those landowners as well, even though we didn't necessarily need their official approval. And they had met with us before this project even occurred. And this kind of, again, is a great way that this kind of fell into our lap and helped us meet a bunch of local goals, is the landowners within this drainage ditch had expressed concerns that the ditch was not functioning properly. So they were seeing water back up into their fields upstream, and they really wanted us to look into what was going on. Is it something we're doing here at Chautauqua, or kind of what's causing that backup in their areas upstream? So if we go ahead to the next slide, Pete. Yep. So basically how we kind of looked at that is we hired JEO to complete a study on this drainage ditch. And basically what we determined, and you had seen this map over here, is that there was a sediment basin right in the area that this two-stage ditch is proposed. So there was originally a sediment basin that was designed when this drainage district was created and the drainage ditch itself was created. So over time, this sediment basin is filled in with sediment. So it is basically no longer functioning as a capture area for sediment. So it's causing water to kind of slow down and back up, and then causing some of that backup in their crop fields upstream. So in this map here is a really good example of JEO ran some modeling, and the green kind of outline areas, that's what's currently happening. So basically what's happening right now without a clean out, as you can say, of that sediment basin. If there would be a clean out, the flood boundary, or what would happen when a 2-year storm event comes, would be in red. So as you can tell, it really help those landowners upstream if a clean out would happen. Well, clean outs are expensive. And in order to do a clean out in a drainage district, you would assess all the landowners and they would be paying for it. So we ran some numbers. It was going to be very costly for us just to do a clean out. And the Board of Supervisors, would have to be the ones that would cover that cost, and they would assess landowners like I mentioned. So this project really meets a local goal there and really helped us get landowner on board, Board of Supervisors on board, because it would essentially serve as a clean out. So it's going to improve the function of this ditch from the landowner side upstream, and then also meet all of those other goals that we have that I mentioned from the other partners of water quality benefits, and all those types of things. So again, a really great partnership, a lot of partners involved, and a lot of different nuances that you have to meet all those partner goals there, which I'll turn over to Juan to kind of talk about how the design had to be tailored in order to meet a lot of those goals.
Thanks, Amanda. Yeah, so looking at the co-design here, this was a pretty major, partnership, joint effort between, ISU, us at JEO, and then Polk County Conservation. I broke it down basically into three big categories. Site identification, there was the permit coordination, and then the design iterations. At each stage involved, tons of meetings. Lots of meetings, getting everyone on the same page, getting input from all the different partners, and making sure everybody was up to speed. And it was every time there was some kind of change. We went through a lot of iterations, just identifying the right location. We wanted to do everything. So first thing I'll talk about here is the site identification, which Amanda talked about briefly. With site ID, like you mentioned, we had that big study area that we looked at. So in looking at that area, we had to identify, which location along this ditch, this project would be possible, where we could maximize the amount of two-stage ditch that we construct, and also where we have, reference reaches that we could use to have comparative data. Luckily, we had this long stretch of drainage ditch right there next to the wetland that we were designing, but we did look at some other alternatives. As you can see on the map right there, there's the primary study area there in purple, and just upstream of that, we had a couple alternative locations in green. Ultimately, we decided with the purple area for a few different reasons. With green, we anticipated some possible issues with the adjacent landowners, or possibly with what the hydraulics look like through the area. There's a lot of factors, a lot of stakeholders for all of these, and ultimately the study area that we went with gave us the longest length, luckily. I know that was a major effort on Polk County side, especially. One of the big things with choosing these, like Amanda mentioned, most of these projects are going to happen along drainage ditches, agricultural fields, those kinds of areas, which gets incredibly difficult to coordinate all that, because you're having to deal with your drainage ditch, your board of supervisors. As you saw in that typical cross section, you're excavating out, which means, depending on the area you're working with, some landowner is going to lose a little bit of crop ground or access ground, which can always be a difficult thing to convince them that it's going to be a net benefit for them. So there's a lot of factors that go into that, ultimately deciding on this location. There were other ones as well, further downstream, and those were ruled out for one reason or another. We have another, as a part of this project, we have another wetland further downstream off that map there, where we had another potential site, but there's issue there with the drainage district and the way that's organized to get something going there. So, so next is permit coordination that I'll talk about here briefly, and I do have another slide that I can go into a little bit more detail a little bit later on. With this permitting, again, that was a major effort between us and especially Polk County Conservation. Amanda here, she did the most of the coordination for the permitting. We just provided some of that documentation that she needed to be able to fill out those applications and those reports in order to get that done. That took design iterations, looking at the different criteria, responding to agency comments, minimizing impacts to the landowners, to the easements, and tweaking here or there as we went between the needs of one agency versus another. That was quite a bit of back and forth there as well. Then with the design iterations, that's where we worked with ISU quite a bit, leaned on their expertise with these two-stage ditches. A lot of that, was optimizing the flow conditions, how often we were getting the overtopping, what the channel shape, the alignment, the footprint all look like. But we at JEO, we have some experience with channel modifications. not necessarily anything like these two-stage ditches. So, me personally, I've worked with a few stream meander designs and bankful benches, but those are a very different situation. The bankful benches, typically, I believe we have an overtopping closer to the 2 or 5 year. So, those significantly higher banks, you're working with, very different hydraulics compared to this one here, where we're looking at regular overtopping just throughout the year. Then in addition to that, like I listed, all the other complexities with the channel shape, that was a permitting challenge, what the alignment looked like, the overall footprint that we ran into, working on easements and adjacent landowners. So if you go to the next slide, that'd be good. So talking a little bit more about the permitting coordination, these were kind of some of the major players, and not just actual environmental permits, but also just regulatory agencies that Amanda had to deal with. One of which, as we're working here in water body here, we had to go through the Corps of Engineers. We were approved for a Section 404 regional permit for reshaping the existing drainage ditches, as well as a NWP number 7 for the outfall structures. These permits have pretty strict requirements for for the channel capacity, making sure that we're not, reducing the capacity of the channel. They have certain requirements for if we're placing any fill, what the shape looks like. Overall, ensuring there's no negative impacts. In addition to that, of course, we're working with the NRCS, as I've mentioned, working within easements. They do have an adjacent property where they have I think it's a WRE easement, correct? So anytime, you're working with those types of easements with special conditions placed on them, it's a process to be able to get permission to alter the landscape in any way. So we're working with them to obtain an MOU, memorandum of understanding, in order to allow us to possibly work in that easement or find some way for us to be able to construct this. And that's one where the shape of the proposed channel and what that footprint looked like has a major impact on that. We want to keep it within the easement, limit the amount we're actually impacting, how high we're placing these berms, the shape, all of that comes into play because everyone wants to protect the land that they have. No one wants to lose their surface area. And of course, along with that, we have typical other ones that we work with, like the DNR, floodplain. And then, of course, a major thing, and not necessarily working with them because they don't give us permits to drainage districts, but they have special permissions. As I mentioned, they're a legal entity, and along with that, they just have special rules they abide by. There's things that they have to do, things they don't have to do, compared to some other public ground. It's just it's a different field working in drainage districts. We do have to answer, or get permission from their boards, but they have special permissions to construct in order to benefit the agriculture sector in the state. Can you go to the next slide? So here I will talk a little bit about the ditch design. This ultimately this is one cross section. We had like a mile of ditch. This is just one of the cross sections there. As you can see from the typical design, or more the ideal design that Peter showed some cross sections of earlier, you can see that on the upper right. Typically, the expectation is you already have somewhat of your base ditch, and you just excavate out your benches in order to create that floodplain. Not as easy to do in the real world, or at least in this specific site, just because of the constraints we had. So, in this one here, slightly V-shaped channel. Other spots, it was trapezoidal. We couldn't excavate that base channel down into the ground because, the upstream end, downstream end, both would be elevated because it's full of sediment. We didn't want to do a full channel clean out. So in order to create that base channel, we wanted to reduce the cross-sectional area of that main channel in order to get the overtopping frequency we were looking for. So that's where we worked very closely with ISU, with Sara to determine what that overtopping frequency we were looking for is. As Peter mentioned, there's a lot of calculations within that. We need to make sure we were getting the frequent overtopping to make sure that the ditch would flow over into his benches frequently enough that we can get the appropriate nutrient reduction and sediment drop off. In addition to that, we also had to be sure that we were getting good velocities through that base channel to make sure that there wasn't sediment drop off in that main channel. We end up filling it out right away, and then it would end up as a trapezoidal channel again. So along with that, you balance some of the things that Amanda talked about as well. We can't reduce capacity. So it might be a little counterintuitive, but even if you are excavating, you can still reduce the overall flow capacity sometimes, the velocity through there, as you increase that cross-sectional area with, and a little bit above my head, or how some of that all ties together. But essentially, when you create these wide areas, you slow down your velocity, and with that and how that interacts with your constrictions on the upstream and downstream end, that can cause a decrease in your overall capacity. And of course, as you can see here, there are sections where we do have to fill in the channel in order to create that base channel size we were looking for. Then, another deviation as well, it's what did the bench width look like? We were shooting for being able to maintain equal capacity as a bare minimum. In addition to that, like Amanda mentioned, one of the big things is using this as somewhat of an alternative to a full channel cleanout. So to kind of account for that, we also included an allowance for sediment storage, which off the top of my head, I believe it was, we increased the cross-sectional area an additional 15% for sediment storage. So we expect some sediment to drop off in here just because of the channel characteristics. It is incredibly flat. I think we had like a 1.5 foot of drop over 4,000 feet or 5,000 feet. It was a very, very flat channel, very low velocities. So we had it was difficult to get the models to come up, produce the cross section we're looking for that would beat all these goals. We leaned heavily on Amanda, especially for the overall footprint. As you can see there, we had to relocate those existing berms. So you can see how they get kicked off to the side. That means, landowners on either side, likely for a good portion of it, Polk County were the landowners. Other portions, NRCS had their easement. There was a portion that was a private landowner. So it was communicating that and figuring out what we needed. I think there's sections there that those berms we need to widen it slightly so we could get farm equipment across the way. So coordinating all that, then of course this is not a typical design in Iowa. So communicating some of this and making it fit under some of the regional permits with the Corps was a challenge as well. I know with the initial discussions we had with them, we thought it was going to be a pretty smooth permitting process, and ultimately we had enough fill in there that we had to pivot a little bit and alter our design and permitting strategy to make things work. So that had a major impact on the ultimate cross section we landed on. Then of course, like I mentioned, ISU was big on determining what that cross section looked like. So as we were running these calcs, we were running a lot of the overtopping frequency, the capacity. We're going through this. We shared our hydraulic models with ISU as well, in order to make sure that all these different moving parts, what the resulting cross section was, ultimately met all the goals that we were looking for. Then beyond the math of it, there's also some of the non-design aspects of these engineering projects that we continue to work together for. So, something that we've been coordinating on is what monitoring is going to look like, what construction is going to look like. That's something that some of their staff isn't as familiar with. So, going to keep them involved in the process, go out there and chat with the contractor, make them aware of there'll be monitoring stations here, here, and here. And what point in the project timeline is it appropriate to, begin monitoring? What is the setting going to look like? What kind of vegetation? What's the typical contractor means and methods, the way they're going to construct this thing to avoid damage to any equipment, choose appropriate times to go out and test. So they'll learn quite a bit from that construction process. We continue to learn quite a bit from them on what goes into the design of these two-stage ditches. Typically, I'm not too familiar with the nutrient reduction side of a lot of this. It's a lot of chemistry and advanced math things that I haven't touched in in a lot of years. But it's balancing that with the hydraulics of it all. Ultimately, the people that get the ultimate say, the drainage districts, and the permitting agencies, they look for a design site conditions that are better than they originally are. So we now have a better design, and we look forward to seeing how this impacts the nutrient reduction. See what Peter and Sarah's guys come out with. Hopefully, we can continue to implement these around Iowa. These are great thing to implement. If we can, there's a lot of drainage ditches out there. As you know how those are constructed, you basically just build a trapezoid, just a straight trapezoid through somewhere. Not exactly a natural shape. So the water likes to do wonky things. This is a little bit closer to the natural state, a little bit closer to equilibrium. I think that's the main thing that I got. I don't know who wants to take lead here on lessons learned.
I can handle this, Pete, if you want me to. So as you can hear from our conversation, there was a lot of nuances to this project, a lot of lessons learned as we're going through and dealing with a lot of partners. So some of the big ones here on the screen, as you can read, is collaboration among all these different sectors and among all these different partners can lead to really impactful research that will hopefully drive a lot of changes or discussion that can maybe be statewide then, which is great. And so, blending a lot of strengths and relationships across the partners. So the next biggest lesson I think we learned is that academic, permitting, funding, all these different timelines they're not often in sync, and you kind of run into hiccups. And so, one partner's timeline may not be realistic for another partner. So I think that that's a big thing that we learned. And then finally, being flexible and adapting is really big. Juan touched a lot on that during the design and having to adapt based on all the different partner needs. So those are really big ones I think we learned, and I'm sure there's many more that we'll continue to learn. But yeah, those are kind of the main ones. And so I think that concludes our presentation. And so if you guys have questions, we're happy to take them and answer those as you have them.
Thank you so much for that talk. I'm not seeing any questions online yet, so we'll go to in the room. Does anybody in the room have a question?
Yeah, on the permitting, was there a single agency that took control of that? I think you said there was the Army Corps, NRCS, DNR, or do they each have their own permitting? And then, and I'm sure that was a process, and a learning process. And do you think you're going to be more streamlined going into the future on this first case learning?
Yeah, so I think I heard the question as kind of, was there one point person or one point organization that kind of handled all the permitting among those various things? And then after this process, do we feel more streamlined? Is that correct?
Yes.
Okay. Yep. So I submitted all of the permits. So Polk County Conservation, as kind of the landowner, we submitted all the permits to those various organizations. And so we kind of coordinated that effort. As Juan mentioned, we worked a lot requesting information we needed for these permits from him. One other big thing we did that we were hoping to help us, it didn't help us as much as we thought it would, is we had a pre-permitting discussion. So we had a call with the Army Corps, who tends to be, I don't want to say they're the most difficult, but they tend to have the most opinions on these various projects. And so we had kind of a pre-permitting discussion with them. That's when we settled on putting it under that regional permit, that regional 41 permit. And then we were able to kind of tailor it to what they had told us originally. So that helped a ton. I would like to say we would be more streamlined in the future. But to be honest, every single project is so different when you submit permits. And there are various reviewers that tend to, have different opinions or maybe just slightly kind of vary on how they handle things. And then also, the Army Corps is always learning new things. So sometimes some of their requirements or wants or desires change a little bit. And so I do think we'll be a little more streamlined in that, like, we know a little bit more of things we maybe have to include up front in the design when we submit it. But I still think, each project is so different that we're still going to have, hopefully not a lot, but some hiccups as we go through the permitting again for other projects. Juan, I don't know if you have anything else to add.
No, yeah, I think that summarizes it pretty well. I mean, I pretty much every project I work on, it's a DNR permit, floodplain, and Corps of Engineers 404. Those are pretty in line. I've done dozens at this point, and every time it is difficult in a different way. Every time, every project's unique. Every reviewer has different opinions. And you get a change in administration at the government level, and that always turns things topsy turvy. So yeah, there's little things that improvements every time. So like Amanda mentioned, we did the pre-application meeting, and that there's some times that doesn't help much, and there's other times that that's turned a 6-month permitting process into a month. It's little things you can pick up here and there, but every project is just so different, so many different requirements, different situation that it's difficult to pinpoint exact ways you can be more efficient.
How long did for this project, how long did the permitting process take?
Oh gosh, was it 2 months? A month? Maybe it was 2 months after all the back and forth, probably. Yeah, it was probably a month, 2 months, I would say. Definitely not as long as if we would have had to do like an individual permit or something like that. But yeah, it was still about a month, 2 months with back and forth.
And we do have a couple online questions. The first one is it realistic or worth constructing meanders and a new 2-stage ditch to aid in natural processing?
I can speak to that one maybe a little bit, then Peter, maybe you can add to it. With meander design, especially in these ditches, it can be a little that depends on the site, what you already have to work with. A lot of the times you may design some kind of meander, and ultimately the stream is going to do something different, whatever it wants to do. Depending on how much earthwork we're talking, how much work, it's very case by case. I definitely err on the side of just going mostly straight or whatever's currently in the ditch, and let nature do its thing and choose its own path, as long as it isn't already meandering into some kind of infrastructure, obviously. As opposed to letting the math determine a meander and going from there. I don't know, Peter, if what you guys have done in the past.
Well, the only thing I would add is that the specific to the constraints from this site, because the gradient is so low, and one of the things we want to prevent is too much sedimentation filling in that low flow channel. We would probably want to maintain as much gradient as we can and avoid meanders in that section of channel. But I would think that that would be kind of a site-by-site consideration. And if there was a pretty steep gradient ditch that you wanted to maybe reduce erosion during low flow, you might take the opportunity to introduce meanders.
There are, and just actually to add to that a little bit too, there are really interesting ways to add the meanders too. I know for some of our wetlands, We'll do just the contractor will just stick basically a shovel and just carve out a very shallow V. That gives the water just enough to grip on to kind of start creating its own path, as opposed to carving out a full trapezoid for the channel for its meander. So there's a lot of interesting ways to do that part of the process.
I know this is a relatively new project, but have you thought about maintenance considerations, what that might look like going into the future, and if there's any need to, or there may be a future need to remove sediment?
Yeah, great question, Kay. I think that was you, Kay. Actually, I'm not sure. But anyways, yes, we have definitely considered maintenance. That's always kind of on the forefront of our minds when we're looking at this because there's always a cost associated with that. So we anticipate that there's probably going to be clean out needs. And so we have worked a little bit with Juan and JEO to kind of determine what that time looks like of like how often we're going to need to get in there, but likely we're going to be just checking it every year and seeing what that deposition looks like. We may be doing the work internally, or with this being a drainage district, it may be up to the district and to maintain that, and they may get assessed for a fee or something like that. And then in terms of vegetation maintenance, we'll just include this we have prairies on both sides, like native prairie. And so we'll include vegetation maintenance when we do maintenance on those prairies, which essentially will be burning. And then if we need to do like maintenance mowing while it gets established, we've already made sure that those floodplain benches are wide enough that we'll be able to get equipment down there and do that maintenance mowing until establishment occurs. So those are the two kind of big maintenance ticket items that we see. But again, if there's erosion that's occurring or a bank is failing, I guess, one of the berms or something like that, we would address that as needed. But that's one great thing about this being such a highly visible site is we'll always have eyes on it to kind of take care of that maintenance there.
Any additional questions from the room? Oh, there was a comment that came in. It was mentioned the Red River Valley of Minnesota, that they have a project team that is kind of confined by a mediation agreement between various partners that seems to help with early coordination.
Yeah, I think that's awesome. And I think we'd love to kind of hear more about that in that process. We have a lot of projects that we use a lot of partners on. So any tips and tricks we can get from people who have been doing it for a long time would be super beneficial. So I think we'd love to hear more about that, if possible.
And then did you all have a couple of additional slides from the INRC at the end?
I do.
Okay. All right, so our next seminar is December 10th at 3:10. This is going to be completely online, and it's going to be Dr. Raj Raman and Brandon Schlottman, who are going to be talking about Valley of Death is Easier with Partners, key learnings from Regen TGC, and where we go next. And next slide. The recording of this webinar is going to be found on the INRC website, and you can also find all of our previous seminars and some additional videos on the INRC website. Right, so I think that is all we have for questions. Thank you again to our presenters. That was great to hear about.
Thank you.
Thank you.
Thanks.